Today we're looking at the Chapter 3 note page on transformations for Integrated Math 1. Right now I'm in box 1A and the directions say plot the points below and reflect across the y-axis. So you start by graphing the 3 points A, B, and C. A is at -3, 4. So starting from the origin, you go 3 to the left and up 4, plot a point and label it A. Point B is at -3, -1. So you go 3 to the left, down 1, plot a point, and label it B. Point C is at -1, 1. So you go 1 to the left, up 1, plot a point, and call it C. I drew it into a triangle, and then I reflected it across the y-axis. So every point over here is going to be the same distance over here. So I counted and said this is 1, 2, 3 units away. So A prime is 3 units away this direction. Point C is 1 unit, so C prime is 1 unit. Point B is 3 units, so B prime is 1 unit. Then they wanted us to find the area of triangle ABC. So I took triangle ABC and I created a rectangle from it. And I found the area of the rectangle by multiplying the length times the width, the 2 times 5, and then the triangle is half of it, so I divided by 2. So 10 divided by 2 is 5 units squared. Moving over to box 1B. In box 1B, they want us to take the same triangle, ABC, and rotate it clockwise about the origin 90 degrees. So if you take your tracing paper, after you plot the same points, A, B, and C, and you put the corner at the origin right here, then you just turn it. Your points are going to end up right where they're shown. So A prime will be at 1, 2, 3, 4, up 1, 2, 3, and B prime will end up at -1, +3, and C prime will be at 1, 1. Moving on to box 1C. This time they want us to translate, so you start with the same original triangle ABC. You're going to move it right 5 units and down 3 units, and then state where each of the points end up at. A prime is at 2, 1, B prime is at 2, -4, and C prime is at 4, -2. All right, jumping over to box 2. So in box 2, it says graph a line that is parallel to the previous line that passes through the points 3, 2. So I graphed the line y equals 2/3 x minus 1. That one I highlighted in yellow. So it crosses the y-axis at -1, has a slope of 2/3, so I went up 2 over 3, up 2 over 3, drew my line. Then I wanted to draw a second line that needed to pass through the point 3, 2. So I went to the right 3, up 2, put a point. I know that if it's parallel, it has to have the same slope. So I went up 2 over 3, and I drew my second line and highlighted it in pink. The equation of the new line is the same slope, so y equals 2/3 x, but this time it passes through the origin, so +0. You can leave the +0 off if you would like. All right. Jumping down to box 3. Write the equation of the line that is perpendicular to the line y equals 2/3 x minus 1. Perpendicular lines are going to have slopes that are opposite reciprocals. So if you have a slope of 2/3 and it's positive, the slope that's perpendicular is going to be -3/2. So you're going to take that fraction and you're going to flip it. Then you're going to substitute it into the equation. I substituted it in here. So I got y equals -3/2 x minus 1. Technically, you can have any number right here, okay? And it will still be perpendicular to that line. Box number 4 says fill in the lengths and areas of the algebra tiles. So if I have x times x, I get x squared. And if I have 7 times x, I get 7x. And then for this box, because it's 2x, and I already have an x here, I know that side has to be 2. And so 2 times 7 is 14. And then this box right here, there's a 6 on the side and a 7 up top, so 6 times 7 is 42. To get the perimeter, I added up everything on the outside of the figure. So there were 4 x's, 1, 2, 3, 4. That's where the 4x comes from. And there were 23 ones, 7, 2, 2, 6, 6, 7. add those up with the calculator, you should get 23 units. For the area, you're going to add up all of the units on the inside. So there's 1x squared. The 7x and 2x combine to get 9x. And then the 14 and the 42 add to get 56, and that's in units squared. All right, flip it over to the back on page 2. Box number 5 says use the area model to distribute. So I put the 5x on the side, the binomial 2x minus 7 up top, and then I just multiplied. 5x times 2x is 10x squared, and 5x times negative 7 is negative 35x. So written as the product, I just put each of the polynomials in parentheses, and then as the sum, I just combined any like terms, which there weren't any, and wrote the answer down as the sum. All right, for box number 6, we have a binomial times a binomial. So I wrote the 2x plus 3 across the top and the x minus 4 down the side. And then inside each box, I just multiplied. So 2x times x is 2x squared. 3 times x is 3x. 2x times negative 4 is negative 8x. And 3 times negative 4 is negative 12. I found my like terms right here, the negative 8x and the positive 3x. Combine to get negative 5x. The 2x squared and the minus 12 do not have like terms. To write the area as a product, I just copied down what was up here in the original question. Box 7a says complete the diagram below. So in this box, I had an x and a y, multiplied them together, got xy. This box was 4y. I knew that is correct because 4 times y is 4y. For this box, 5 times an x, got 5x, and 4 times 5 is 20. So the area as a product, I just took the top, the x plus the 4, and the side, the y plus the 5, right here. And then for the area of the sum, I combined any like terms, which there weren't any. So I have xy plus 5x plus 4y plus 20. In box 7b, it says to find the perimeter in figure A. So that's why I labeled the other two sides, because on perimeter you want all of the outside. And I have 2 x's, that's where that comes from. And then I had 2 y's, this side and this side, that's where that comes from. And then the numbers I added up and I got 18, and that's 18 units. Right. Down in the 2 bottom boxes, the directions say to simplify the terms. If you're adding x's, you say 1x plus 1x, that's 2x. If you multiply x's, you add the exponents, so x times x is x squared. 3x plus 6x is 9x. 3x times 6x is 18x squared. For this one right here, there's no like terms, so you can't simplify. It's just 2x plus 6y. And then when you multiply 2x times 3y, you get 6xy. The very last box says to simplify. It just so happens that 8 goes into 16 twice. The x squared and the x squared completely cancel. The y to the 5th and the y to the 5th completely cancel. And the only thing left is 2. Everything inside these parentheses needs to go to the power of 3. So I took the 2, took it to the 3rd power. I took the x to the 3rd, took it to the 3rd power. And I took the y to the negative 1st and took it to the 3rd power. Then I simplified the exponents. So 2 to the 3rd is 8. With these exponents, you multiply, so you get x to the 9th. With these exponents, you multiply, so you get y to the negative 3rd. These two guys are fine, so they stay in the numerator. This negative exponent moves down to the denominator. You have 8x to the 9th over y to the 3rd.